Now we're going to look at our last lesson in Unit 8, Lesson 9, and this is over variation, direct, joint, and inverse. And this is how do numbers change in relation to other numbers. So first we're going to look at direct. Now the model for a direct variation is y is equal to k times x, where k is a constant and x and y can change. An example of a direct variation would be like your pay. If you work more hours, you get more pay. What's the constant in that scenario? Well, the constant would be your hourly wage. It's not going to change. But if you input more hours, then that's going to cause an increase in the output, which is your pay. So that's direct. Now, joint is quite similar, and it is k times x times z. We have an additional factor there. An example of this might be your savings account, because what's going to affect the balance in your savings account? Well, you would have a principal, you would have a rate, and you would have a time. So as any of those went up, the value of your account is going to go up. So that's still sort of a direct variation. It's just there's more factors in it. Okay. Now inverse is different. Inverse means it goes the opposite way. The model for this is k over x. An example of an inverse variation might be your checking account. The more money you spend, what happens to the value of your account? Your value goes down. So that's what an inverse variation looks like. For each of these three examples, we want to identify the type of variation and the constant. If you notice on all of your models, what do you have to start with? You have y equals. So before you can match it to a model, you have to convert it to that form. Right? This one is already y equals some number times x. So of course, this is your direct. And what is your constant? Well, it's the number multiplied by x. So your constant is 2. All right, on this one, we do not have the correct format. I have y divided by x. So I need to get rid of the x. Since y has been divided, I'm going to multiply both sides by x. Now I have y equals 2/5 x. So you can see 2/5 is my constant, and this is also a direct variation. It is direct, and the constant is 2/5. All right, let's look at this last one. I have 3y equals x. I need to get y all by itself, so I'm going to divide both sides by 3. Now I have y is equal to x over 3, and it's very tempting to say, oh, this must be inverse. But you know what? It's not. Because your inverse function has your constant over your x. And we don't have that here. We have x over a constant. What you actually have here, since your x is on top and your constant's on the bottom, that's how you know it is not inverse. What it is 1/3 times x. So this is also a direct variation, and your constant is 1/3. So now let's work a problem involving these models. If y is directly proportional to x, and y is equal to 28 when x is equal to 7, find x when y is equal to 52. Now you have two different scenarios going in here. You have a given scenario, and then you have a what if scenario. So since we're told that it's directly proportional, we're going to be using y equals k times x. So let's take our first instance here. Y is 28, so let's plug that in. We don't have a k, so leave it k, but x is 7. Now if I solve this for k, my constant, how am I going to do that? Well, k is multiplied by 7, so I'm going to divide by 7. And now I know that my constant is 4. Now let's take this constant, which doesn't change, and fill it into the next part of the scenario. Now I want to find x when y is equal to 52. So if I fill in what I know into my direct variation model, all right, y is now 52 equals, k is what I just found here. So it's going to be 4. X is now what I'm looking for. And you have a simple equation to solve. Divide both sides by 4, and your x is now 13. So here's our next problem. If y varies jointly with x and z, and y equals 48 when x is 8 and z is 15, find y when x is equal to 14 and z is 20. Now, just like the other problem, we're going to fill in the original scenario to find the constant, and then we'll pull those numbers out and put these in with our constant and see what y is. So first, let's take the model for joint variation. Y is equal to k times x times z, and we'll fill in what we know from our first scenario right here. All right, y is equal to 48. K, we don't know. That's what we're trying to find out. X is equal to 8, and Z is equal to 15. Okay, so 48 is equal to, all right, 8 times 15 is 120. So you have 120K, and we're going to divide both sides by 120. So K, our new constant, is 48 divided by 120. So that's 0.4. Now, let's take just the constant, and we're going to come back to this. We're going to fill in our new numbers with the constant. Now, we don't know y, because this says find y. So our new equation is going to be y equals k, which we now know to be 0.4, times x, which we have to be 14, and z, which we're told is 20. And then we'll just multiply these together real quick. 0.4 times 14 times 20. So our new y is 112. So if it's whichever model it tells you to use, you're going to fill in to find k, then take k and fill in with your new information. Okay, in this problem, if y is inversely proportional to x and y equals 7.5 when x is equal to 8, find x when y is equal to 5. Now, just like with the other two, we're going to take the model for the inverse variation, which is y equals k over x, and we're going to fill in the original information, which will still leave k blank, but that's going to let us find k. And then we can use k with our new information to back up and find x. All right, so our first one says y is equal to 7.5 when k, which we don't know, over 8. Now, here's your equation. How do you solve this? Your variable is divided by 8, so you're going to multiply both sides by 8. So k, your constant, is equal to 8 times 7.5, which gives you 60. Okay, now that's the first half. Now we're going to take the same model, we're going back to the model, and we're going to fill in k and y, and we're going to solve it for x. So I have 5 equals, k is on top, which is 60, and y is, and x is what we don't know. Okay, now how do you solve this? Well, multiply both sides by x. This is the long version. So now you have 5x is equal to 60, and then divide both sides by 5. So x is equal to 12. Okay, the last thing we want to look at is some combined variations, where you have a mixture of these. And we just want to write the model for y varies directly as x and inversely as z. So, thinking about your models here, direct variation is multiplied, inverse variation is divided. by the constant. So y varies directly means y equals, all right, if it's directly as x, that's k, your constant times x, and inversely as z is just going to be divided by z. So this would be the model of y that varies directly as x, because as x goes up, y goes up, but inversely as z, because it's divided by the z. One last combined variation problem. A varies directly as b and inversely as c. If a is equal to 16, when b is 12 and c is 6, find a when b is equal to 28 and c is 4. So first let's get our model. A varies directly as b is going to be that a is equal to k, which is your constant, times b, and then inversely as c. So this is what your model is going to look like. A is equal to k times b over c. Now, first, we're going to fill in the original amounts. A is equal to 16 equals k, which is what I'm trying to find, times b is 12 over c, which is 6. Now, I'm just going to solve this real quick. Multiply both sides by 6. So 16 times 6 is 96 equals 12k. And then you would divide both sides by 12. 96 divided by 12 is 8. So my constant is 8. That's what's not going to change. Now I can take that constant back up into my model. I'm going to fill it in for k and these new values for b and c, and then I'll solve it for a again. So I'm missing a this time. I know that my constant is now 8 times b, which was 28, over c, which is 4. And the quick math on that is going to get us 8 times 28 divided by 4, which is 56. So that is your new value.